Robotics is an interdisciplinary branch of computer science and engineering. The goal of robotics is simply to create machines that can perform specific tasks that can help and assist humans. We are a group of engineering undergraduates introducing a customized product to be used for extensive robotic applications. A robot's ability to perform its job securely and safely is heavily dependent upon understanding of its path and surroundings. Here's where robotic navigation becomes an important approach in robotic development. Robotic navigation can be defined as the combination of three fundamental components: self-localization, path planning, map building, and map interpretation. However, robot navigation is a far more complex task than it appears to be. The intended outcome of this project is to design and develop a device for tracking and navigation of a mobile robot with respect to a given starting point. Before moving to our solution, let's go through some available methods to achieve these tasks. GPS, robot odometry, LiDAR, and LoRa are some of the available methods for position tracking, and to measure the orientation, gyroscopes, accelerometers, and magnetometers are used. For more accurate orientation measurements, dual GPS systems are available under research level. Some of the above position measuring devices have some practical issues such as low accuracy, limited number of applications, high dependency on external parameters, high cost, and high processing power. In spite of these practical problems, the main issue we identified is that these methods can be used only for specific applications under limited conditions. In addition to that, an external module for orientation tracking needs to be used along with them to achieve the expected outcome. When considering these issues of the existing methods, we realized that it is more beneficial to develop a product with higher accuracy, which can be used in different applications according to the customer requirements.
So now let us introduce our product Mobotricks. Mobotricks is an intermediate level development board designed especially for robotic applications, with the capability of navigation, tracking, and rapid prototyping of a robot. The board contains an inbuilt digital signal processor to calculate orientation and other navigation-related data using inertial measurement unit. It is designed along with I2C, USB, and SPI ports, which allows the customer to use as an optional module for position tracking and data transmission, depending on the type of application. In the navigation tracking application, the board merges data about data above sensor data from and performs error reduction through Kalman filtering. Then it outputs the navigation and orientation of the robot with the high accuracy. Apart from that, the board itself be used as a development board for any other application, mainly robotics. Now it's time to introduce the main concept of this design. The board has high baud rate, which makes the real-time tracking possible. And it is capable of giving out the real-time orientation, speed, and acceleration of the mobile robot with its inbuilt component and sensors. To name, NPU 9250 processor, which has 9 degrees of freedom with gyroscope, magnetometer, and accelerometer. Depending on the application, the user can connect external modules such as GPS, odometry, and LiDAR to give the positional inputs to the board through the input ports. After that, the ARM processor can be used to filter out the noise and other disturbance of the signals to get more accurate results. It is also designed with the ability to program using Arduino IDE, which allows it to have many online assistants and resources.
So as mentioned earlier, here we mainly focused on getting an orientation measurement output with a high accuracy and give the opportunity to the user to choose the position measuring technique depending on the type of application. So one of the key features of this product is it has inbuilt I2C and SPI ports where user is able to connect an external measuring unit. The board is capable of handling measuring techniques such as odometry, GPS, LoRa, and LiDAR, etc. with its processing power. Another feature is the product itself has an SD card to store the navigational data so that in applications where the real-time data cannot be used straight away, the user can analyze the problem with stored data in a favorable environment. Also, board has an inbuilt USB and a serial port for data transmission, where Bluetooth, Wi-Fi or RF modules can be directly connected to the board depending on the user requirements. The product consists of a mobile application where the user can install and connect the development board using Bluetooth or Wi-Fi to read and analyze the output data using the mobile application. Okay, now let's move on to some main advantages of Mobotricks, which makes it a better solution for mobile robotic applications compared to existing products. Mobotrix has a high baud rate of nearly 32 MHz, which makes it possible to achieve real-time tracking more conveniently. The angle measurements have a high accuracy with 9 degrees of freedom. Since there are ports where different position modules can be connected, the board can be used for a variety of applications both outdoors and indoors. When talking about Mobotrix as a commercial product, it has a competitive price point with the available market solution. It is a durable and user-friendly product which has a low space consumption. So when considering above facts, Mobotrix can be introduced as an optimum solution for developers to use for their mobile robotic projects and applications. This will be an ideal solution for them to make their tasks easy in the process of rapid prototyping, real-time 2D orientation and position tracking, navigation analysis, and obtain acceleration and velocity measurements. It is an added advantage that the product can be adapted according to the external conditions and limitations of the applications through externally connected modules and data transmitters.
After customer purchases a Mobotrix development board, there are few easy steps to be followed to set it up for their robotic applications. First, the mobile application issued with the product needs to be installed to their devices. Depending on the application and the data transmission method, the user can connect the suitable position module and the data transmission module to the board. Then, the user can obtain the output measurements by connecting the board to the mobile application via the output module. Now, let's move on to the brief description of the procedure followed to design and implement Mobotrix. After initial brainstorming session and researching, a block diagram and a work plan was designed, including the expected functionalities of the product. The most suitable circuit component for the product were chosen by referring to the data sheets of the variety of components and processors available for each task. The PCB design of the development board was designed using KiCad software, and the components were arranged neatly to make the outer appearance of the product more attractive as the board itself is the final product. After getting the final design, MATLAB was used to implement and program a Kalman filter for error reduction. The measurement data from user input, such as wheel encoder, GPS, LiDAR, and LoRa, are fused along with the measurement obtained through the inbuilt sensors. Then Kalman algorithm applied to reduce the error and obtain the optimized result. Bluetooth or Wi-Fi used to connect development board and the mobile app, which is developed along with the board to visualize the results.
After designing the PCB, it was handed over to a specialized PCB soldering company to get the final product done, as advanced PCB soldering technologies are not available in Sri Lanka. While the PCB implementation was being processed, a differential robo was designed and implemented for hardware testing to measure the orientation using gyroscope module and to measure position using encoder odometry. We also implemented separate test circuits for orientation and position measurements using Arduino and tested them using the differential robo.
For orientation measuring, at the beginning, the test circuit was implemented using MPU 6050 sensor, which consists only 3-axis gyroscope and 3-axis accelerometer. To achieve a higher accuracy level, the sensor was replaced with MPU 9250, which consists of magnetometer along with two above modules. For position measuring, a test circuit was implemented using encoder odometry. A Bluetooth communication module was also implemented to get the output through an application. After the PCB design, it is manufactured, necessary components can be soldered, and we hope to do necessary test and debugging with different robots under different conditions.
As viewed in the video, we used Webot software for simulation of Kalman filtering, which is used for error reduction in velocity measurement. Here, the velocity measurement obtained from inbuilt sensors of the board were used as the model input to Kalman filter, along with the velocity measurement obtained through the odometry as the plant input. When comparing the output of the Kalman filter, shown in red plot, with the real velocity curve, which is shown in blue plot, we can conclude that rather using only an encoder for position measuring, with the implementation of Kalman filter, an output with a higher accuracy can be obtained for velocity measurement. Using the same technique, we have done error reduction for orientation, position, and acceleration measurement as well in our final product.
The above described product development progress so far can be visualized from our summarized timeline here. Few more developments of the hardware implementation and some testing and debugging needs to be implemented to finalize the product. As future expansions of this product, we hope to develop an operating system specially devoted for robotic applications. At the moment, the board is capable of obtaining real-time 2D measurements with a high accuracy. The error range of the Z direction is comparatively high when compared with that. We hope to increase the accuracy to make the product to be used for real-time 3D measurements. We also try to increase the capabilities of the processor for applications that need higher computational power.